we were talking about indices, surds, and the logarithms. And this indices part we have already finished, right? And solving exponential equations, and also we added a few examples about exponential equations and surds. And also yesterday I uploaded this chapter into the classroom system. Okay, you can download the file and you can practice some questions. In the final exam, for each question you will have around 3 minutes, so you need to practice how to solve questions fast. Okay. Okay, so we were talking about logarithm. Today we are going to talk about two different logarithms, special logarithms, let's say. The first one is common logarithm. Okay, because in general we know that when we just say that logarithm, here we have if y, not y, let's say here we have b is equal to a to the power x, right? And when we just convert this into logarithmic form, here we have x is equal to logarithm of b to the base a. Okay, but now here we are going to talk about a special logarithm when this base is equal to 10. Okay, that is commonly used when we are evaluating logarithms or a lot of things. That's why actually it deserves to be, how to say, we need to attach a special name to this. That's called common logarithm. Simply, if the base is 10, when we just write this in this form, logarithm of b to the base 10, we just call this common logarithm. For example, logarithm of b, for example, just sometimes within this 10, we just omit this base, or we just write here logarithm of b. In some books, they just write LGB. These are all the same things. What is it? The base is 10. Logarithm of b to the base 10, or logarithm of common logarithm of b, common logarithm of b. When we just say common logarithm of b, we don't have to mention it is base, okay? Because we know that the base is 10. So logarithms that have a base of 10 are known as common logarithms. The values of common logarithms can be readily obtained from tables of common logarithms or by using the log key on a calculator. Usually we use LGX or log x to denote logarithm of x to the base 10. And also, actually, I don't know if you remember in public schools and maybe Khmer books, usually in all books at the back of the math book in grade 9 or grade 10, there is a table of common logarithm. Okay, sometimes, for example, you are not allowed to use a calculator. Let's say you are given the value of, for example, logarithm of 2. Okay, you know this value. And also, you know the common logarithm of 3, for example. Okay, then they ask you, okay, this is given, without using a calculator, evaluate what is common logarithm of 6, for example. Okay, how can I do that? If I know its value, let's say it is a, let's say this value is b. From here, using the property, I can write it as logarithm, common logarithm of 2 times 3, which is equal to common logarithm of 2 plus a common logarithm of 3, right? And this thing I know that is given here, it is a, and also this thing is given here is equal to b. So I can write here that is a plus b. Okay, because in all classical exams, even this says it might be given in this way. They are just measuring your skill. How can you deal with logarithmic equations? Okay, this manipulation. Can you just simplify this, adding something, dividing by something, blah blah blah. Okay, they are not measuring your calculation skill, because if I want to evaluate this thing, right, I can just key in the calculator, I can get the value. But actually, just if this thing is given, right, without using calculator, I cannot evaluate this if I don't know the properties of logarithms. Okay, usually how this appear in the exam, because nowadays in real life, if you have to calculate, you don't have to know this, right? Just use this one and evaluate. This is a calculator. But in a lot of stuff when you're dealing with a kind of problem, so you have to deal with logarithmic equations. So you should be familiar with their properties. Okay. Okay, all properties are the same. The only difference is here base is 10, so we are going to call this common logarithm. Solve the following equations, giving your answer correct for significant figures. That means it is 4 significant figures. Okay, guys, you have to also be familiar with this thing. Okay, if you have never seen this word before, you can just search in the Google and have a look. Let me just give you brief information about this significant figures. Significant figures means we have two different ways we can write a number, right? Sometimes let's say that write your answer correct to 2 decimal places or 5 decimal places, whatever it is. But sometimes we need to write our result correct a certain number of significant figures. Okay. In math, the significant is, let's say, important or the most important. All right. For example, if we are given a number, let's say your answer is here, writing something corrected for significant figures. Let's say here 1, 2, 1, 6, 7, 8, 0, 1, for example. How can you write this number corrected for significant figures? That means that starting from the first non-zero number, take the first 4 digits. These are the importance for us. And the rest, we have to, if these numbers are after the decimal point, we have to round off. If it is just a part of whole number, when it is just convert this into 0. When we are doing this, after this number, what is the next digit? It is 8. If it is greater than 4, we just add 1 to the previous digits, right? Otherwise, just change them into zeros. So if I change this into correct 4 decimal significant figures, the answer would be 2, 1, 6, 8, 0, 0, 0. So correct the 4 significant figures. Okay, I'm just explaining here because in the exam, if I tell you write the correct answer corrected 4 significant figures, if even one digit is wrong, your answer is wrong. It may be very close, even your solution is correct, but also you should know, do you actually know how to write a number, correct a certain number of the significant figures? Okay, that's why you should be careful. Another example, for example, let's say 0.01234567, for example. How can you write this number corrected for significant figures? Starting from the first non-zero digits. Okay, what's the first non-zero digit? It is 0, 0, starting from here then. Now count 4. 1, 2, 3, 4. So these digits are important for us, significant for us. The rest we have to just round off. As you see here, after 4, a number is greater than 4 again. So I should add 1 to the previous digits and just drop this, because even if I just, actually, I am changing them into zeros. But here, since these digits are after the decimal point, we don't have to keep them here. So that the answer will be 0.0123, because of this 5, that is 5. Okay, that is 4 significant figure representation of the given number. Okay, and one more example. Let's say you are just dividing something. For example, let's say 2 over 7. All right, and when you just divide this number, what we get here, 2 is divided by 7. Okay, the answer is, here we have 0.2857 142 857 857. It continues. Anyway, so how can I write all the digits here? I cannot. So if they ask, okay, the first 4 digits are important for us, write this answer correct to 3 significant figures, for example, let's say, or 4 significant figures, doesn't matter. So if the first one is 4 significant figures, and here we 3 significant figures, here let's write 4 significant figures. Here's 3 significant figures. So the starting from the first non-zero digit, that is 2. So 1, 2, 3, right? And the rest, it is 7, greater than 4. So I should just drop the rest and add 1 to the previous digit. So the answer will be 0.286. So correct the three significant figures. How about 4? It is 1, 2, 3, 4, and this digit is less than 4, less than 5, so it is 0.2857. Correct. What is it? 4 significant figures. Okay, there's no dot here. All right. That is the meaning of significant figures. Okay. So now I'm going to solve these equations one by one, since now we know that's what we mean by significant figures. The first one is logarithm of 3x minus 2 equals 1.24. So here we have question A, logarithm of 3x minus 2, 3x minus 2 equals 1.24. 1.24. So we have to solve this equation. And you know the idea, right? The only thing here is, what I'm going to tell you here is, first, we have to change this into exponential form, and some students, they just calculate in every step. But in this kind of questions, to get accurate answer, you need to use your calculator in the final step. The first step, if you convert this into exponential form, right? Using the definition, here we have common logarithm. That means that base is 10. So that is equivalent to this equation. 3x minus 2 is equal to, that's the base 10, and that is the exponent. So here we have 10 to the power 1. Okay, that is 1.24. Okay, so some students immediately, they just evaluate this and solve for x. That is not correct, okay? Because if you just do this, use a calculator in every step, when you just evaluate this, it does not give us the exact answer. So you have to truncate or you have to round off, which actually, how to say, causes some error. As you go further, your error gets bigger and bigger. That's why you should not use calculator here, all right? First write everything, find x, then in the final step, you need to use a calculator. Okay, in the final exam, if you make such a mistake, I will not accept this. Okay, if you don't know this, it is your problem. That's why I'm telling you here. That's really important in scientific calculations, because you need to keep your error in the minimum level. So if you just solve this, it's just a number here, right? And here we have linear equation. So how do we solve this? That's 3x equals, take it to the right hand side, 2 plus 10 to the power 1.24. Right? And divide both sides by 3, so that x is equal to 2 plus 10 to the power 1.24 over what I have here, 3. Now I can write my answer here. So x is equal to, okay, correct the 4 decimal places. In this step, I can use a calculator. So in the numerator, we have 2 plus 10 to the power 1.24 is divided by 3, which is equal to, when you write the answer, that is 6.4593 and 3, and here we have 6 and continues. All right. So if I want to write this correct, the 4 significant figures starting from the first non-zero digit, so that is 6. Take the first 4 digits. So these are 4 digits, 1, 2, 3, 4. And the next digit is less than 5. So actually I should just drop this. So the answer is x equals 6.459. Correct, the 4 significant figures. Okay, this is how we solve this kind of logarithmic equations. Question B. Okay. Question B. What is question B? 7 to the power x plus 1 equals 9.5. So 7 to the power x plus 1 equals 9.5. Have a look. 7 to the power x plus 1 equals 99.5. So we need to find the value of x. Okay. How can I do that? Assume that you have a table of common logarithm. Okay. Using just common logarithm without using a calculator, how do you do this? All right. Actually, take the common logarithm of both sides. Here we have LG 7 to the power x plus 1 equals, here we have LG 99.5, right? And using the property of logarithm, this comes to the front. So here I have x plus 1 times common logarithm equals common logarithm of 99.5. Now, if I just divide both sides by this and take one to the right-hand side, what do I get here? That x equals common logarithm of 99.5 over, here I have 7, right? Common logarithm of 7. And also here we have 1, take to the right-hand side, here we have -1, okay? So now if you evaluate this, what we have here? Here we have logarithm is 99.5, and here we have -1, which is equal to 1.364013 and dot dot. Okay, so our answer will be dot dot dot. X will be, we have to write our answer corrected 4 decimal places, right? I mean, not 4 decimal places, significant figures. So starting from the first non-zero digit, that is 1, 1, 2, 3, 4. The next digit is less than 5. You can just drop off the rest of the digits. What I write here is 1.364. That is the solution of the given logarithmic equation corrected for significant figures. Okay, that is B. And how about C? Let's change our pencil color. So we have to solve this thing. Okay. I don't need this line. Let me just start here and we'll continue next page. So to solve this problem, here we have 1.1 over 2 times 5 to the power x plus 34 times 5 to the power minus x. So I will solve this by introducing an auxiliary variable. Let's say w, use w to label this 5 to the power x. Now what we have here then? Here I have 1 over 2w plus 34 times w to the power -1. That is 34 over w equals, on the right hand side, we have 12, right? Or if you just multiply by 2w, multiply both sides by 2w. These two to cancel each other, w times w, so here we have w squared plus, here w, they cancel each other, 2 times 34, that is 68, equals 12 times 2w, that is 24w, right? Or as you see here, just a quadratic equation, so I can solve this using the formula w squared minus 24w plus 68, that's equal to 0. Okay. Can we solve this by factorization? 17 times 4 and the 34 times 2, it doesn't work. The only way is we need to use the formula, right? Let's find the discriminant. Let's equal to b squared, 24 squared minus 4 times 1 times 68, which is equal to 24 squared minus 4 times 68, which is equal to 304. 304. So that is W1 equals 24, right? Negative B, that is 24 minus B. It is plus square root of discriminant 304 over 2 times A. A is equal to 1, so here we have 2, right? And that thing is equal to what? 5 to the power x. 5 to the power x. And W2 equals 24 minus square root of 304 over 2. Also, that thing is equal to 5 to the power x. Right? So from here, I can just evaluate what is it, W1 and W2. Right? Just take the common logarithm of both sides and evaluate this. What we have here is, if we continue the part C, if you just look at the first one, for example, take the common logarithm of both sides, what we have here? Common logarithm of, here we have 24 plus square root of 304 over 2. That is equal to common logarithm of 5 to the power x, right? And the second thing is minus, okay, just this comes to the front, then we get the first solution of x1. That is equal to what we have here, common logarithm of 24 plus 304 over 2, and here we have common logarithm of 5. Okay. The second is the same. I can just write here x sub 1 and x sub 2. I can just write here minus. If you evaluate when it is plus, we get the first solution. Minus, you get the second solution. Right? So now we can write the answer. So x1 equals something and x2 equals something. Okay. So let's evaluate x1. x1 is, here we have fraction and common logarithm of, again, another fraction, 24 plus square root of 304 over, here we have 2, and close the brackets, over, it is common logarithm of 5 equals, so it is 1.88326, 88326, but correct the 4 decimal places, 1, 2, 3, 4. So that is the answer. So that's less than 4, 5, we can just remove it. So correct the 4 significant figures. How about the second thing? We have the calculator, right? You only change the sign here. So just backward and change plus into minus. So it is minus, that's equal to, the answer will be here 0.7384384, and it is 6 something. So starting from the first on 0 digits, right? So we just drop this. So here we have 5. So this will be 5. That is 5. Correct 4 significant figures. Okay, gentlemen. All right. We also one more question. Now let's have a break. It is 10:55. Okay. We will continue next session. Okay. At 11:05 or 11:10, I will continue the next session. Okay, have a break now.